Good day, class. In this video, I will construct and fill out the parametric table of a Cartesian manipulator. Okay, so Cartesian manipulator has 5 frames. So our rows are 5 minus 1 is equals to 4. So we have 4 rows. Then the 4 parametric table. Okay, so we will start filling out the columns of theta, then next the columns of alpha, then next the columns of r, and then lastly the columns of d. So again, we will start from frame 0 up to frame 1. So this is the homogeneous transformation matrix 1, reference or relative to frame 0. Okay, so theta is the required rotation to match x sub n minus 1 to x sub n at z sub n minus 1. So our frame n minus 1 here is the frame 0 and our frame n is this. Okay, so our x sub n minus 1 is x sub 0, our z sub n minus 1 is z sub 0, and our x sub n is x sub 1. Okay, so the rotation required to match x sub 0 to x sub 1 is 0 degrees. Okay, so why 0 degrees? Because x sub 0 and x sub 1 is already at the same direction. Okay, next is frame 1 and frame 2, theta of frame 1 and frame 2. So this is for the homogeneous transformation matrix of 2 relative to 1 or reference to 1. Okay, so our frame n minus 1 now is frame 1, then our frame n is frame 2. Okay, our x sub n minus 1 is x sub 1, and our z sub n minus 1 is z sub 1, then our z sub n is z2. Okay, sorry, x sub n is x sub 2. So again, theta is the required rotation angle to match the x sub n minus 1. This is the x sub n minus 1 to x sub n. Okay, so we will rotate counterclockwise at z sub 1. Z sub 1 is the axis of rotation. So counterclockwise to match x sub 1 with x sub 2. So this rotation is only imagination. Okay, but I will simulate it here in my OneNote. So this is z sub 1. We will rotate here to have a theta. This is x sub 1. This is x sub 2. So to match x sub 1 with x sub 2's direction, we will rotate counterclockwise. So this is not counterclockwise. This is clockwise. The counterclockwise is here. Okay, this is clockwise. Okay. So sorry. This is counterclockwise. Okay, this is counterclockwise. Okay. To determine the rotation, if clockwise or counterclockwise, you may use your right hand. Okay. This is also a right hand rule. Your thumb is the z-axis, then the four fingers are the direction of rotation. Okay, so your thumb is pointing backward, then your x sub 1 is pointing to the right, So rotate to the right. So this is counterclockwise. Okay. This is counterclockwise. So from right, you will rotate up to here to match with x sub 2. So the amount of rotation is 270 degrees. Okay. So this is 270 degrees. After rotating, I will return it to its original position because this is just imagination. This is just imagination. I'm just simulating what you need to imagine. Okay. Next, for the homogeneous transformation matrix of frame 3 reference to frame 2, theta. Okay. So our frame n minus 1 now is frame 2 and our frame n is frame 3. Okay. So our z sub n minus 1 is z sub 2. So the rotation, counterclockwise rotation will happen here. This is x sub n minus 1, x sub 2, and x sub n now is x sub 3. So x sub 3 is pointing at the front, x sub 2 is pointing upward. So if we rotate counterclockwise at z sub 2, so counterclockwise, again, you may use your right hand for the right hand rule. Okay. Z sub 2 is pointing to the right. Okay. X sub 2 is pointing upward. Counterclockwise to match with x sub 3. Okay. So you need a 90 degrees rotation. Okay. So 90 degrees. Okay. Next, after obtaining the rotation angle, return the x sub 2 axis to its own direction. Okay. Next is the theta at the homogeneous transformation matrix of frame 4 relative to frame 3. Okay. So frame n minus 1 now is frame 3 and the frame n is frame 4. Z sub 3 is the Z sub n minus 1. Okay. Z sub n now is the Z3 is now the Z sub n minus 1. X sub 3 is X sub n minus 1 and X sub 4 is the X sub n. So the rotation will happen at Z sub 3 counterclockwise again, but we don't need to do that because x sub 3 is already at the direction of x sub 4. So our theta here is 0 degrees. Okay. So this is the theta. Okay, this is the theta for this mechanical manipulator. Next is alpha. Alpha is the required rotation or required angle at the x sub n to match z sub n minus 1 to z sub n. So let's go back to the base. Okay, to start to obtain the alpha for the homogeneous matrix of frame 1 relative or reference to frame 0. So our axis of rotation now is x sub 1 because it is the x sub n. Okay, we will match z sub 0 to the direction of z sub 1. Okay, perform the rotation alpha counterclockwise again. Okay, so x sub 1 is the thumb, z sub 0 are the four fingers pointing upward. Then the direction of the closing of the four fingers will be the counterclockwise direction. So the amount of rotation to achieve the direction of z sub 1 is 270 degrees. Okay, this is 270 degrees. Okay, 270 degrees. Okay, so 270 degrees. Next is the alpha at homogeneous matrix of frame 2 relative or reference to frame 1. So our x sub n now is x sub 2. Our z sub n minus 1 is z sub 1. And our z sub n minus 1 is z sub 2. The rotation will happen at x sub 2 when we perform the rotation alpha. Z sub 1 will rotate counterclockwise to match Z sub 2. So this is counterclockwise. Okay, from here up to here. So the amount of rotation is 270 degrees. Okay, so this is 270 degrees. Next, for the alpha of homogeneous transformation matrix 3 relative or reference to 2, reference to frame 2. So the x sub n now is x sub 3. The z sub n minus 1 is z sub 2. The z sub n is z sub 3. Okay. So z sub 2 must rotate along x sub 3 axis. So let's perform the rotation. Let's perform the rotation alpha at x sub 3. So from right direction. Okay, so the amount of rotation is 270 degrees. Okay, so this is 270 degrees. Then for the last homogeneous transformation matrix, okay, our x sub n is x sub 4. Then our z sub n minus 1 is z sub 3. Our z sub n is z sub 4. We don't need to rotate. We don't need to have rotation alpha here because z sub 3 is already at the direction of z sub 4. So this is 0 degrees. Okay. So we are finished at column alpha. Next is parameter R. So parameter R is the distance of the origin of frame n and frame n minus 1 along x sub n. Okay, so let's go back to the base at homogeneous transformation matrix of frame 1 reference to frame 0. So our x sub n is x sub 1. Okay. X sub n is x sub 1. So along x sub 1, we don't have a linked length. Okay, along x sub 1, we don't have a linked length. Okay, because we don't have a linked length at the axis of x sub 1, our R here is 0. Okay, this is not 0 degrees. Okay, remember, this is not 0 degrees. This can be inches, foot, or millimeters, or centimeters, or meters. Okay? Only the rotation angles are the degrees or radian, while the position parameters are either inches, feet, millimeters, centimeters, or meters. Okay? So next is homogeneous transformation matrix of frame 2 reference to frame 1. Okay. At x sub n, Now our x sub n is x sub 2. Okay. So the distance of frame 2 to frame 1 along x sub 2 is also 0 because along the axis of x sub 2 there is no link lengths. Okay. This is x sub 2. X sub 2 is pointing upward. There is no link lengths upward. Okay, along the axis of x sub 2. Next, along the axis of x sub 3, because x sub 3 is the next x sub n for homogeneous transformation matrix of frame 3 relative or reference to frame 2. The distance between frame 3 and frame 2 is also 0. Okay, because there is no link length along x sub 3. And lastly, for homogeneous transformation matrix of frame 4 relative or reference to frame 3. Okay. Along the axis of x sub 4, the distance between frame 4 and frame 3 is also 0 because there is no link length along x sub 4 axis. Okay. Next is the column D. We'll start again from the base. The homogeneous transformation matrix of frame 1 relative or reference to frame 2. So this is the distance between the origin of frame n and frame n minus 1 along z sub n minus 1 axis. Our z sub n minus 1 axis here is z sub 0. Okay. So the distance between the origin of frame 0 and frame 1 is a sub 1. Okay, a sub 1 because a sub 1 is along z sub 0 axis. Okay, it is along z sub 0 axis. So we will write here a sub 1. Okay, next, for the homogeneous transformation matrix of frame 2 relative or reference to frame 1. Okay, so the distance between frame 1 and frame 2 along z sub 1. Z sub 1 now is the z sub n minus 1. Okay, so it is a sub 2. So we will write here a sub 2 because a sub 2 is along z sub 1 axis. And with a sub 2, we have a given joint variable d sub 1. Okay? Because this is a prismatic joint. Okay, this is a Cartesian manipulator. So all our joints are prismatic. So we will have an additional d for every d in each homogeneous transformation matrix. So this is A2 plus d sub 1. Okay? A2 plus d sub 1. Next, for homogeneous transformation matrix of frame 3 relative or reference to frame 2, the distance between frame 2 and frame 3 along z sub 2 axis, because z sub 2 is now the z sub n minus 1, is A3 because A3 is along z sub 2. And we have here again another prismatic joint. The given joint variable is D2. Okay, so A3 plus D2. Okay. Next is the D at the homogeneous transformation matrix of frame 4 relative or reference to frame 3. Okay. So the distance between frame 3 and frame 4 along z sub 3 axis, because z sub 3 axis is the z sub n minus 1 at this homogeneous transformation matrix. So the D is a sub 4 with the given joint variable D3. Okay. Joint variable D3. Okay. So this is the complete homogeneous transformation matrix of this Cartesian coordinate. Sorry, Cartesian coordinate. Cartesian manipulator. Okay. So after this, we will plug it in our formula, standard formula of homogeneous transformation matrix for as a step for DH notation. Okay, let's get the formula. Okay. So how to convert this parametric table into homogeneous transformation matrix? So first, I will copy this for H01. Okay. So H01. So this is H01. So to confirm if our answers are correct, I will use a calculator, scientific calculator. Okay. So this is H01, this first row. Okay. So what we will do here is we will substitute the value of theta, alpha, r, and d in this standard formula of the homogeneous transformation matrix. So this will be theta 1. Okay? Oh, we don't have theta 1 because this is not a revolute joint. Okay? So this is not theta 1. Sorry, this is theta 1. N is equals to theta 1. Okay? N describes the row. So this is theta 1. This is theta 1. This is theta 1. Okay? This is D sub 1. This is also D sub 1. This is D sub 1. This is theta 1. This is alpha 1. Alpha 1. Theta 1. Alpha 1. R1. Theta 1. R1. Theta 1. And D sub 1. Okay. Only one D. So, we will get theta 1 here. So, theta 1 is equals to 0 degrees. Why? Because this is the first row. So, theta 1 is 0 degrees. So, we will substitute all theta 1. Okay, we'll make this 0. This will become 0. Okay, wait. So, I will copy this again. Okay. So, this is 0. Zero. This is 0. This is 0 again. This is negative. Okay. This is 0. This is 0. Okay, 0. Sin theta n. Sin theta 1. So, this is sin 0. Okay. Negative cosine 0. Okay. This is cosine 0. Then this is sine 0. Okay. Next, substitute the value of alpha. So alpha is 270. So this will become 270 cosine 270. It's also 270. This is 270. This is sine 270. Okay. Then sine 270. And cosine 270. Okay. Next, the value of r. The value of r is 0. So this one is 0. Okay, this will become 0. So this is 0. This is also 0. Then d sub 1 is a sub 1. So we don't have a value for a sub 1 yet, but d sub 1 now is a sub 1. Then simplify. Okay. Let's simplify this. Copy again. Okay. So let's use a calculator to check what is cosine theta, cosine 0. So cosine 0 is equals to 1, while sine 0 is equals to 0. So everything with sine 0 is already 0. Okay, whatever is whatever is sine 270. Whatever sine 270 or cosine 270. If they have a variable of sine 0, it will become 0. So what is cosine 270? Cosine 270 is 0 also. Okay. Sine 270 is equals to negative 1. So sine 270. So cosine 0 is 1. Okay. Cosine 0 is 1. Sine 0 is 0. Negative sine 0 is 0. So this is already 0. Okay. Cosine 0 is 1, but cosine 270 is 0. Am I right? Cosine 270 is equals to 0. So this is also 0. Next, sine 270 is negative 1. Then sine 0 is 0. Okay. Cosine 0 is 1. Sine 270 is negative 1. But negative 1 times negative 1 is positive 1. Cosine 270 is also 1. Oh, sorry. Cosine 270 is 0. Okay. Cosine 270 is 0. So this is also 0. This is also 0. Then this is 0. Then a sub 1. So this is the homogeneous transformation matrix of frame 1 relative or reference to frame 0. Okay. So you may do this for the next homogeneous transformation matrix. Okay. So this is faster if we have MATLAB. So for now, let's uh, let's fully understand first how parametric table is constructed or filled out. Okay? Because this substitution part is very easy. we need a faster software, which is MATLAB or Python. Okay? So that we can perform faster substitution and multiplication of 4 by 4 matrices. Okay? So this is the, again, this is the D-H Parametric Table of Cartesian Manipulator.